to review inductive and deductive reasoning. Can anybody with a raised hand explain to me how we use inductive reasoning? Colt.
We just use
What we see, but what in particular? 2 words I'm looking for.
our common sense.
No. Go ahead. Patterns and behaviors. Okay? Yes. Patterns. Okay, sorry. I didn't mean the word and. Patterns and behaviors. What you're looking for inductive. What are we looking for deductive?
Research.
Okay, research. Facts. And then definitions. Good. And accepted properties. Look at him on the ball. So, number 1. This is not anywhere on your notes. We're just going to talk through these to review. Because on your quiz and your test, it will literally say, is this inductive or deductive reasoning, and why? Okay, so your why should be, we used a pattern or behavior. And then we used facts. That's the other. Yes?
So this is due tomorrow?
Can we talk about that at a later date? Not in the middle of what I'm trying to teach? Not because of... You have to focus. Okay. A chemistry experiment produced the same result 20 times. You conclude that it will always produce the same result. Are they using facts or patterns? Patterns. So that would make this inductive reasoning. I'm going to try IND. Tim is Veronica's cousin. Since David is Veronica's twin brother, Tim is also David's cousin. This is deductive. Adrian's your brother, right? Mm-hmm. Okay. So I'm going to use her as an example. Okay, Tia. Tia's cousin is Kayla Newman. That was news to me, right? She is? I'm not wrong? Okay. Because Tia's brother is Adrian, his cousin is also, I think, right? Yeah, also Kayla Newman. Okay? So because they're siblings, they have the same cousin. Okay? So what happens is, and they specified twin brother, because there are some odd instances where your sibling doesn't have the same cousin. But here they specified especially twin brother. So deductive because these are straight up facts. Okay? Number 3, the school librarian notices that many students are requesting books about different countries in Africa. The librarian concludes that one of the social study classes must be studying about Africa. Inductive. Okay, inductive. Okay, because she's looking at a pattern. She does not know the facts. She thinks this, but really, there could be one of them has a long-lost brother from Timbuktu, and you just want to learn about it. My father-in-law is from Timbuktu. We've talked about this, yes?
We have talked about how your husband's from Africa.
From Africa, yeah. Timbuktu, Mali. It's in West Africa. Yeah. Anyways, so that's why I bring that up. Anyway, so number 4. Number 4 is probably the hardest one because the way it's worded. It wouldn't be like this on the quiz or test. It would be very obvious which one you would use. Okay. So this one kind of can go either way, but I'll explain why I decide the reasoning I decide. Julie notices that each term in the sequence 1, 3, 9, 27 is found by multiplying the previous term by 3. She concludes that the next 2 terms are 81 and 243. What do you think I mean by the way that they word it? You did not answer my question. What do you think by what I mean, how they worded this problem? What wording would make me question whether it's deductive or inductive? She notices. Julie notices. So this means, is she stating a fact or watching a pattern? Watching a pattern. So this is why I would be more inclined to say inductive. Okay? Again, this one really you could make a fight for either way. Okay? But I would say because the way it's worded, it's more inductive reasoning. Okay? Number 5, given the sequence 19, 23, 27, 31, you conclude that the next term will be 35. All right, so is this a fact or a pattern? Pattern, so it's also inductive. We know that all men are mortal. What does mortal mean?
Human. Can die.
You can die. Yeah. All men can die. Since John is a man, John is mortal. Okay? These are deductive because these are all facts. Okay? Fact, fact, fact. All of the people that you met in town are very strange. You conclude that everyone in town is very strange. Inductive. Okay? First guy I met was a weirdo. Second guy I met, weirdo. His mom, weirdo. So everyone must be a weirdo. Okay? Definitely inductive pattern. Okay? I'm not saying it, they said it. All right, so what we are going to do today is we're going to finish our notes. So we're on the second to last page. So find where we left off. You will probably want a couple of colors. A few colors. This part was hard for some students and easier for others. It was easier for students that wrote what I told them to write. Okay? Wrote what I told them to write. So, is your hand up, sir?
No.
Okay. It looks like it. The first one, law of detachment. That's the blank at the top of that page. Law of detachment. So that's the first blank. You should be filling in law of detachment. All right, so you see, if P then Q is a true conditional statement and P is true, then Q is true. That's already written on your paper. Here's what's not. Okay? In order for you to make a conclusion, the hypothesis has to be fulfilled. I want you to write that down. In order to make a conclusion, the hypothesis has to be fulfilled. In order to make a conclusion, the hypothesis has to be fulfilled. And I will explain all of that with our example. Okay? So again, in order for us to make a conclusion for detachment, this is the law of detachment. Sorry, you just really like it. So in order to make a conclusion, the hypothesis must be fulfilled. Here is going to be our example. If you study, then you will get a good grade. Okay, so it's not on this paper. We're just making a statement, okay? If you study the right things, then you would make a good grade. If you study the wrong things... Okay, so if you study, then you will get a good grade. Notice how I color-coded it. What does the red represent? P, also known as the hypothesis. And then what does this light blue represent? Q, which is the conclusion. Okay? So what will happen is, Ruby studied. What can you conclude? Does Ruby studying fulfill the hypothesis? Yes. It says if you study. Well, guess what? Ruby studied. So what can we conclude from this? She will get a good grade. So Ruby will get a good grade. Do I need to write it?
No. Please don't.
Okay. Please don't. Ruby will get a good grade because this fulfills the hypothesis. Let's look at our next one. Anne got a good grade. What can you conclude? Pause. You have to listen to what you just wrote down. In order to make a conclusion, in order to come to a conclusion, what has to happen? The hypothesis has to be fulfilled. So these are two separate problems, okay? Anne got a good grade. Does this fulfill the hypothesis?
No.
No. So you cannot conclude anything. So the answer would be not possible or cannot conclude. Okay? Because again, in order for us to use the law of detachment, P is a hypothesis, P has to be fulfilled. That's why when Ruby studied, we could conclude she got a good grade. You cannot do the reverse. You can't say Anne got a good grade because she studied. You don't know. Anne could be very good at test taking. Some people are. Okay? So in order to use the law of detachment, the hypothesis has to be fulfilled. Okay? We're going to do the example that you have. All right, so let's look at it. It is right below. If a figure is a square, it's the same, yes?
Yeah.
Okay, if a figure is a square, then it is a rectangle. You know that quadrilateral ABCD. So keep in mind when you see something like that, that means there's a four-sided figure named ABCD. Okay, that's all that means. Is a square. Using the law of detachment, what statement could you make? Okay, so let's look at this. In my first sentence, what is my hypothesis? A figure is a square. What is my conclusion? It is a rectangle. Now let's look at the statement that they gave me. You know that quadrilateral ABCD is a square. Does this fulfill the hypothesis?
Yeah.
Yes, it does. Quadrilateral ABCD is a square. So if it fills the hypothesis, we can come to a conclusion. What would our conclusion be? Yeah, so don't use the word it. But yes, you're on the right track. Yeah, quadrilateral ABCD is also a rectangle. Okay, so you would take the subject, quadrilateral ABCD, and you'd write it with the conclusion, is a rectangle. So that is the answer that you will write. Quadrilateral ABCD is a rectangle. So be writing it down. You're going to make this a lot harder on yourself if you don't write down what I'm telling you. Okay, I'm telling you. When you go to do your classwork, you'll be like, I don't know how to do this. Okay, and some of you will be a rock star at it because you followed along, wrote your notes. Okay? Next example. If you have a doctor's appointment, then you will miss a half day of school. So here's what happens. What is my hypothesis? If you have a doctor's appointment, so you have a doctor's appointment. Conclusion. You will miss a half day of school. So let's read what they gave us and see if we can make a statement. You had a doctor's appointment yesterday morning. Does this fulfill the hypothesis?
Yes.
Yes, it does. So can we make a conclusion? Yes. So if you have a doctor's appointment, then you will miss a half day of school. Well, you had a doctor's appointment. So what do we know about you? You missed half day of school. So that's the law of detachment. The hypothesis has to be fulfilled, okay? In order for you to have a conclusion. It's okay. What are you saying?
The answer tag
Oh, well, it is what it is.
Written incorrectly.
Is it?
Yeah. You missed the first half day of school.
Yeah, whatever.
Why omis?
Yeah.
It happens. Well, I don't know why it's not on my screen. It is what it is. It is what it is.
Oh, yeah.
You get it. All right, law of detachment. The next one is harder for students. This is where your colors will come in. Okay? We're going to learn the second law. Okay, it's called, are we okay to move screens?
Oh, yeah, Miss Marshall.
Okay. Well, this morning I was accused of going too fast.
Nah, Miss Cruz, Miss Jones.
So you know I'm recording, right?
Oh.
Congratulations, that was Ian and Justin.
What? No, that was
Come get them.
What? That was not cold. That was just.
I was about to.
Oh, that just never went. Anyways, law of syllogism. It is the weirdest word in geometry. Congratulations, you've hit this point. So you want to write it in. Justin, you want to write it in. Law of syllogism. Okay, so here's what you remember about the transitive property. Okay, remember how it would be like if A equals B and B equals C. What do we know about A and C? They equal each other. Okay,
Oh my goodness.
they both equal B, yes, but they equal each other. It'd be like me saying Noah is the same age as Kaylee. That's the right name, right? Okay, I don't know why I doubted it when I said. I remember Viscano. That's how you say your last name. And then I was just like, no, I'm just completely ridiculous. Okay. Noah is the same age as Kaylee, which is the same age as Marcus. Okay, so he's the same age as her. She's the same age as him. So what can we deduce about Marcus and Noah? They're also the same age because those two are the same age. These two are the same age. That means the first and the last are the same age. So here's what's going to happen. It's going to be very similar. Okay, what's going to happen is you're going to have a couple of statements. You're going to have if P then Q and Q then R are true conditional statements, then P and R will also be true. Here's what I want you to know. This is what your answer will look like. What you need to be able to do is you're going to need to figure out which one was P and which one was R. Okay? If you notice, in both of our statements, PQ, QR, what letter overlaps?
Q.
Q. You're going to need to figure out which one overlaps. Notice how Q in the first statement is the conclusion, and in the second statement it's the hypothesis. Here's what I want you to write down. There must be, whatever's in common, must be a hypothesis and a conclusion. So whatever they have in common must be a hypothesis and a conclusion. Or you can say they must have a hypothesis and a conclusion in common. This will help you so much on your homework, classwork, whatever, if you write this down. Okay, the hypothesis and the conclusion, wherever they overlap, one of them has to be a hypothesis and a conclusion. I will explain. So a statement, the statement that overlaps, has to be a hypothesis and a conclusion. Okay, not of the same sentence. You're not going to say if you get a good grade, then you got a good grade. Like, that doesn't make sense. But what's going to happen is I'll show you my example. If you study, then you will get a good grade. If you get a good grade, then you will pass the class. So here's what I want you to know. You need to figure out what overlaps. What two statements are mentioned? Well, what one statement is mentioned twice? You will get a good grade. So this would be considered the blue, the Q here. Okay, notice. So we got those. Now we need to decide what is the P and what is the R. Notice how P always represents what part of a conditional statement? The hypothesis. All right, so let's look at our first statement. If you study, then you will get a good grade. We know then you will get a good grade was a part of what overlapped between the sentences. What is if you study? The hypothesis. So you're going to actually underline it. I'm going to underline in red. You can underline whatever color you want. The next sentence, okay, where it overlaps, if you get a good grade, that was our hypothesis. Then you will pass the class. That was our conclusion. So I'm going to underline that in green so that it matches what we got going on up here. I will explain. What did you say? It's not on your notes, I know.
What the heck, Miss Marshall?
So we have to write it?
You don't have to write it, no. You can follow along. You can write it if you would like. It's also on the internet in 5 minutes. Okay? So what will happen is our answer will look like if P, then R. So what's going to happen is you're going to leave out in your final answer, you're going to leave out what overlaps. So you will get a good grade will not end up in our final answer. Here's what will. What represents P in this entire thing? If you study. So our final answer in a conditional form would be if you study,
You will pass the class.
Then you will pass.
then you will pass the class. Exactly. Then you'll pass the class. So you leave out what they have in common. You leave out the two sentences that overlap. Then you use the hypothesis as the hypothesis, and you use the remaining conclusion as the conclusion. Okay? I think I even had, like, you studied, what would our conclusion be? You studied, you passed the class, which we just did. You passed the class, technically you wouldn't have a conclusion to that, because that doesn't fulfill any of the hypothesis. That's like the ending note. All right, so here's just in picture form. If hypothesis P, then the conclusion Q. Then you'll see Q become a hypothesis. Then conclusion R. Then you'll take the hypothesis and the conclusion that don't overlap, and you'll form a sentence. Okay? This is in your textbook if you would like that picture. Okay? We're going to do these examples as well as the ones on your paper. So listen to what I did. Okay? My first class struggled with this, so I threw in extra examples. Okay? So if you want to close the notes and write on the back of them, something to that extent, but you have a homework problem like the first, and then we actually have an example together like the second. So I would write down the first one. Write down A, if x squared is greater than 25. That's what I would write down right now. You can write down a blank part of your paper. So just write down the part that says A, if x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. I'm telling you right now, there's a problem on your classwork. I think it's number 22, don't quote me, but it's around there. That looks like this. It's math. It's similar. Okay, it has the same structure as this one. So which law are we using here? What does it say? Syllogism. So think of like silly, I don't know. And then gism. Yeah, I don't know. Anyway, so what part do they overlap?
The x squared.
X squared, well, there's a ton of x squared. What phrase do they overlap?
X squared over 20. 5.
Okay, why are you saying over? Y'all know what this sign means?
Greater
Greater than what?
Greater than 25.
Wow, thank you. Wow. All right, is one of them a hypothesis and one of them a conclusion?
Yeah.
Yes, so we're good there. What happened here is it's not written in the order that we were used to. We were used to the opposite order, okay, where this was P, I'll write it. This was P. Then this one was Q. This one was Q. And then this one was R. That's what we're used to. Okay, but you can still use the law of syllogism because the phrase that overlaps, one of them is hypothesis and one of them is a conclusion. Here's what you do. You're going to make a conditional statement. Well, if we disregard the part that overlaps, do we have a hypothesis left and a conclusion? Yes, we do. Yeah, we do. Hypothesis, conclusion. So what we do is we make a sentence with them. What's my hypothesis that's left? If x is greater than 5, what's the conclusion that's left? Yeah. Oh, that's not a 2. That's what your final answer would be. You look at, sorry I didn't outline the if. If what you look at is the overlap has to be a hypothesis and a conclusion, and then you disregard them, you take what's left, and you form a conditional statement. So we took if x is greater than 5, then x squared is greater than 20. Okay, this next example you don't necessarily have to write down because it's pretty dang close to yours. On your paper, I'll explain this. If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all its sides are congruent. Where does it overlap?
If the polygon is regular.
Thank you. If a polygon is regular, is one of them a hypothesis and one of them a conclusion?
No.
No. So we cannot use not possible. So this one would be not possible.
Oh, yeah, Miss Marshall.
Okay, because one of them has to be a hypothesis and one of them has to be a conclusion. Okay? We're looking at your two examples. Yours on your paper. I think it'll pop up. Yours on your paper. So go ahead and look at that last page. It was pretty close to the one that we just did. Letter, we're going to do letter B then letter A. Is that okay with you?
No.
Letter B then letter A. Get over it. If a figure is a rectangle, then all interior angles are right angles. If a figure is a square, then all interior angles are right angles. What part overlaps? The conclusions overlap. They both say, then all angles are right angles. Can we use the law of syllogism if the overlapped are both conclusions? No, one has to be a hypothesis and one has to be a conclusion. So you would write not possible. This is why I said we'll do A next, because I had this one. It's the last one we do. A, if soccer practice is canceled, then you go to the mall after school. If it is raining today, then soccer practice is canceled. Where is the overlap? Soccer practice is canceled. Is one of them a hypothesis and one of them is a conclusion? Yes. So now we're going to take what's left. So I'm going to kind of cross them out just so we can see what's left. Where's the hypothesis that's left? If it is raining, there's my leftover hypothesis. So that's going to be my new hypothesis. If it is raining, what's my leftover conclusion?
Then you can go to the mall.
Then you can go to the mall after. Then you can go to the mall. I'll be laughing over there. After school. Handwriting's beautiful. It is what it is. Ta-da! So that's the law of syllogism. Okay? Questions? Do you need me to explain any of them again? Why did we do this? Why wasn't it this?
No.
Okay.
Teach did great, Miss Marshall. Yeah.
Thank you, Cole.
Give her a hand, yeah.